Let's dive into those 5 key components when we're evaluating fan array system. Let's dive into each one of those a little bit further, just to give you a little bit more detail in terms of what we're looking for. So the first one, the design and selection. There have been many studies of fan array manufacturers and also people within the industry to determine the proper layout of systems, and in terms of how the length of the array, the number of fans in the array, and then the diameter of the fans in that array, how they all come together and play an important role in the proper design and selection of a fan array. So studies of these systems have proven that when there's a ratio of the sides of the array to the number of fans and impeller diameter, if that ratio is greater than or equal to 1.55, there's typically no loss of performance. That's because when that ratio is at that level or greater, it really provides enough space around the fan impellers for the airflow to fully develop and helps negate any system effect that might occur. So that's an extremely important aspect when we're looking at fan array designs, to make sure that we have the proper selection and arrangement of, as I said, the length of the array versus the number of fans in the array and the diameter of each one of those fans. The second thing we look at is sound performance. So while it may be true that more fans equal more noise, it's important to understand that we're comparing much smaller fans in the array to the old single large horsepower fan. And typically when we look in that, it's basically a wash in terms of the sound performance, and we even get better sound performance with the fan array. Just because fan arrays use fans with smaller impellers, they emit noise in the higher frequency bands, which are much easier to attenuate. And it also, should be noted that when we have a fan array system, a direct drive EC fan motor, we're really eliminating a lot of the vibration noise that can come with a single fan from the pulley and shivs, and just the amount of moving parts within that mechanically driven belt drive fan. We're really eliminating a lot of that vibration that can create noise, as well as create other problems within that air handling unit based on the vibration of that unit moving forward under full load. So sound is very important. The third thing we look at is the operation and control. Typically, in the industry now, we have variable air volume systems, so that single fan is controlled by a VFD, and it's responding to that fan is either sped up or slowed down to match the load and airflow requirements downstream of the air handling unit. When we get into a fan array system, it operates very similar, but what we're really looking at is not putting a VFD on each individual fan itself. We're putting a VFD controller on the array as a whole. So as one fan drops off, or as system characteristics change downstream of that air handling unit, based on the programming and the sequencing, that drive is going to control the fans at a different way. It's going to speed them up at certain percentages and things like that. And then if we have a loss of one fan, the sequence is programmed so that the other remaining fans that are in operation are going to speed up and deliver the same amount of airflow with a reduced number of fans as it was providing with the original design normal operation number of fans moving forward. So control is very similar. We're using a VFD or a modulating controller that is going to respond to the changes in the space and in the system downstream of the air handling unit, just as it was if it was a single large fan with VFD. The fourth thing we're looking at, and this is one of the main benefits of this type of technology, is the redundancy. Single fan systems typically present a single point of failure, and that's a massive risk, especially in hospitals when those air handlers and those fans are serving critical spaces. When we go to a fan array system and we have multiple fans within that array, they're more reliable and require less maintenance than belt-driven fans because they have fewer moving parts. When one or more array fans fail, the other fans can compensate automatically. There's no loss in performance and no risk associated with any type of patient safety or comfort issues downstream. So when we're looking at continuous operation and things that when we need to have that reliability or redundancy, the fan arrays are ideally suited for critical spaces moving forward. So it's definitely one thing that we use a lot in our hospital clients, and it's something that allows them to really operate their spaces worry-free without the risk of failure or loss of revenue or any type of patient safety risks. And the final thing we look for is the operation and maintenance of that unit. With multiple smaller fans, the fan array is much lighter and easier to install and maintain without any big equipment. Most of these fans are at a weight and size that they can be carried by hand by one individual through a standard opening door. And they don't require lifts or multiple people or a lot of labor-intensive effort in order to move parts and pieces in and out of that air handling unit in order to provide routine maintenance, preventative maintenance, or in the event of a failure, the replacement of that unit. So it's just a smaller, lighter, modular nature of the fan arrays that allow all the pieces to be able to be moved in and out with relative ease, making it reducing the costs and downtime significantly moving forward. The fan arrays also occupy less floor space within those air handling units than large belt-driven fans, which allows accessing and cleaning and maintaining these fans much more easier and efficient moving forward, since your maintenance staff is not going to have to climb around a lot of pieces of equipment or squeeze in and out of access doors within an air handling unit. It allows them to more comfortably take tools in with them and work on these fans as needed without really actually even turning the system off or really losing any type of operational performance downstream of that while they're working on this unit. So, in summary, fan array technology is tremendous. It's allowing us to do a lot of really great things for our clients and help them solve problems, with the redundancy and with the risk of downtime, where we just have clients and processes and systems that can, need to function without any downtime. And if there's any types of failures, those failures need to be addressed immediately and not really be known downstream to the people in the space and have that type of impact down where we might have patient safety issues or loss of revenue. So, to kind of sum up, what we look for in our fan array systems is the design and selection of the fan array. Again, that's the length of the array itself versus the number of fans and the diameter of the fans. We're concerned about sound performance. We're looking at the operation of control of that unit. How are we going to adapt to changes in system requirements? The redundancy, like I said, which is extremely important, that allows the unit to operate worry and risk-free moving forward in the event of a fan failure. And then the operation and maintenance considerations for your team moving forward. How are they going to maintain this unit? How are they going to fix it, repair it, and keep it up and running without any impacts to the people downstream that are being served by this piece of equipment? So we hope you found this helpful, and please, as always, reach out to Synergy Consulting Engineers if you have any questions or need any help. Thanks.